Good day! Today, we are presenting the security hardening implementation of our web application, SafeTrip Explorer PH. This project focuses on integrating secure coding practices and server hardening techniques aligned with the OWASP Top 10 security risk. In this demonstration, we will showcase authentication, role-based authorization, service-side validation, CSRF protection, HTTP security headers, and vulnerability assessment using OWASP.
Let's go!
So let's open Incognito. When a user is not authenticated, they are limited to accessing only public routes such as the landing page, login, and registration pages. Now let's manually type dashboard. Now, we will try to enter incorrect password. When invalid credentials are submitted, access is denied. Now let us also try to enter correct credentials. Upon successful login, the application generates a secure JWT-based session using Nextdoor. So let's try to log in as regular user. Here, a regular user attempts to access the administrator panel. The backend verifies the user's role before granting access, and since the role does not have sufficient privileges, access is denied. When authenticated as an administrator, access is granted. This demonstrates strict server-side role enforcement and adherence to the principle of least privilege. So, to demonstrate that validation is enforced on the backend, we send requests directly to the API using Postman, completely bypassing the front end. When valid data is submitted, the server processes the request successfully. When malformed data is submitted, the server responds with a 400 validation error. Even when attempting to inject a privileged row directly into the request body, the back-end validation prevents unauthorized role assignment. All incoming requests are validated using ZOD schemas on the server. We do not rely solely on client-side validation. This prevents injection attacks, unauthorized data manipulation, and database corruption. After authentication, the application issues a secure session cookie. The HTTP-only flag prevents JavaScript from accessing the session token, reducing XSS risk. The secure attribute ensures cookies are transmitted only over HTTPS in production. The same site policy limits cross-origin requests, mitigating CSRF attacks. These configurations help protect against session hijacking and cross-site request forgery. The application also implements HTTP security headers to mitigate common web-based attacks. Content security policy restricts allowed sources of executable content, reducing XSS risk. Strict transport security enforces HTTPS communication and prevents downgrade. These headers provide protection at the HTTP layer, adding an additional defense layer independent of application logic. And let's open Zap report. We conducted automated vulnerability scanning using OWASP. The initial scan identified configuration weakness and missing security headers. After implementing mitigation strategies, a rescan confirmed reduced or eliminated medium and high-risk vulnerabilities. So, this demonstrates a full vulnerability assessment and remediation life cycle.
So this diagram presents the threat model for SafeTrip Explorer PH. It identifies our critical assets, potential threats, and the security controls we implemented. Our high-value assets include user credentials, role data, and booking information. These must be protected from unauthorized access and manipulation. Based on the OWASP Top 10, we identified major risks such as broken access control, injection attacks, CSRF, and security misconfiguration. To mitigate these threats, we implemented layered security controls including secure authentication with password, hashing, role-based access control, server-side validation, CSRF protection, secure cookies, HTTP security headers, and HTTP encryption.
These protections follow a defense-in-depth strategy, ensuring multiple layers of security across the application. This threat model guided our implementation and was validated through vulnerability scanning using OWASP. In conclusion, SafeTrip Explorer PH has transitioned from a functional application to a secure platform. By integrating secure authentication, RBAC, and server-side validation, we've ensured that data integrity is maintained at every touch point. By applying security at multiple layers from encrypted transit to hardened server configs, we have significantly reduced our attack surface. Our defense-in-depth approach ensures that even if one control fails, the system remains resilient. Thank you.